Rounding and absolute value functions are fundamental tools in mathematics and programming, often used to manipulate and manage numerical data. These functions play crucial roles in various applications, from financial calculations to data analysis. The absolute value function returns the distance of a number x from 0 on the number line, regardless of its sign. In programming languages such as Lua, the math.abs function is used to compute the absolute value of a number. For example, math.abs -5 returns 5, as the absolute value of -5 is 5. Rounding functions are used to approximate a number to a nearby integer or specified decimal place. Two common rounding functions are math.ceil and math.floor. Math.ceil with argument x rounds x up to the nearest integer. Math.floor with argument x rounds x down to the nearest integer. Additionally, custom rounding functions, such as math.round, can be defined to round a number to the nearest integer. These custom functions typically utilize math.floor or math.ceil along with a specific rounding logic. Understanding and mastering these rounding and absolute value functions is essential for accurate numerical computations and data manipulation tasks in programming. An absolute value represents the distance of a number from 0 on the number line, regardless of its sign. So, for positive numbers, the absolute value remains the same, but for negative numbers, it becomes positive. In the provided example, the absolute value of x, it is the same because 4.5 is already positive. The absolute value of y remains also the same because 5.8 it is also positive. However, the absolute value of z becomes positive because -4.5 is negative and its absolute value is 4.5. So, even though the values of x and z are different, their absolute values turn out to be the same because absolute value measures distance from 0, not the direction. Let us dive deeper into the next example and discuss why we get the results we do, as well as the differences between them. The math.ceil function in Lua rounds a given number up to the nearest integer, which could be positive or negative, depending on the input value. It does not strictly go to positive, rather, it rounds towards positive infinity when dealing with negative numbers. First, let us break down our code. Variable x equals 4.5. The math.ceil function rounds x up to the smallest integer greater than or equal to 4.5. The result is 5, because 5 is the smallest integer greater than 4.5. Variable y equals 5.8. Again, math.ceil rounds y up to the smallest integer greater than or equal to 5.8. The result is 6, because 6 is the smallest integer greater than 5.8. Variable z equals -4.5. Here math.ceil rounds c up to the smallest integer greater than or equal to -4.5. This might seem a bit tricky, but it's important to remember that math.ceil rounds towards positive infinity. So, the result is -4, because it is the smallest integer greater than -4.5. Understanding the behavior of math.ceil function is essential for tasks like rounding up prices, calculating quantities, or any situation where you need to ensure values are rounded up to the nearest integer. Variable x equals 4.5. The math.floor function returns the largest integer less than or equal to 4.5. The result is 4, because 4 is the largest integer that is less than or equal to 4.5. Variable y equals 5.8. Again, math.floor returns the largest integer less than or equal to 5.8. The result is 5, because 5 is the largest integer that is less than or equal to 5.8. Variable z equals -4.5. For negative numbers, math.floor still returns the largest integer less than or equal to the given number. Since c is negative, the result is -5 because it is the largest integer that is less than or equal to -4.5. The math.floor function rounds a number down to the nearest integer. It always returns a value less than or equal to the input number. When dealing with negative numbers, math.floor returns the next lower integer. Math.floor rounds down, while math.ceil rounds up. Math.floor moves towards -infinity for negative numbers, while math.ceil moves towards positive infinity. Their behavior is opposite when it comes to handling decimal values. Math.floor removes the decimal part to go down, while math.ceil increments the integer to go up. Understanding these opposite characteristics helps in choosing the appropriate rounding method based on the specific requirements of your program.